Let's begin today's topic, time, speed and distance. The concept underlying the chapter of time, speed and distance are amongst the most important for the purpose of math section in aptitude exams. The basic concepts of TSD are used in solving questions based on motion in a straight line, relative motion, circular motion, problems based on trains, and problems based on boats, clocks, races, etc. Besides, these concepts can also be used for the creation of new types of problems. Your ability to solve these problems will depend only on the depth of your understanding. Due to this diversity and the possibilities for question setting, this chapter is very important for CAT aspirants. Besides, all other exams based on aptitude also require the use of TSD. This chapter is one of the most important chapters in the entire portion of quantitative aptitude. You people are therefore advised to closely understand the concepts contained in this chapter to be comfortable with the problems related to this topic in the examination. Theory of TSD. The first concept is concept of motion and mathematical representation of your motion. Motion or movement occurs when a body of any shape or size changes its position with respect to any stationary point, external stationary point that is. Thus, when a person travels from a city A to B, we say that he has moved from city A to B. In general, whenever a body moves with respect to a stationary point, we say that the body has undergone a displacement with respect to the starting point. Thus, for a motion to have occurred, there must have been some displacement with respect to a stationary point on the ground. The mathematical model that describes the motion has three variables, namely speed, time, and distance. Speed, time, and distance. The relationship between these three is also the most important formula for this chapter. That is, speed into time is nothing but distance. The given equation is the mathematical description of the movement of a body. In complex problems, students tend to get confused regarding the usage of this equation and often end up mixing up speed, time, and distance of different motions of different bodies. I must mention here that this formula is the cornerstone of the chapter time, speed, and distance. Besides, this formula is also the source of various formula applied to the problems on the applications of time, speed, and distance to trains, boats, and streams, clocks and races, circular motion, and straight line motion. In the equation, speed can be defined as the rate at which distance is covered during the motion. It's measured in terms of distance per unit time and may have any combination of units of distance and time in the numerator and denominator respectively. That is, you can say meters per second, kilometers per hour, or meters per minute, or kilometers per minute, even kilometer per day, etc. Time. Time is the time duration over which the movement or motion occurs or has occurred. The unit used for measuring time is synchronous with the denominator of the unit used for measuring speed. Thus, if the speed is measured in terms of kilometers per hour, then time is measured in hours. Distance. Distance is the displacement of body during the motion. For distance, we use small d, for time, we use small t, and for speed, we can use capital S. Now, here, the thing is that when we say that the speed of a body is what? S kilometers per hour, we mean to say that body moves with S kilometer per hour towards or away from a point that is stationary. So, suppose this point is stationary. So, we will say that that body is moving with the speed of S kilometer per hour towards or away from this point. So I hope you understood that what is speed, what is time, and what is distance. The next concept is proportionality is implicit in equation speed into time equal distance. Now, direct proportionality between time and distance when speed is constant, that is, time is directly proportional to distance. Let's understand this concept with the help of a question. So here, what does the question says? A car moves for 2 hours at a speed of 25 kilometers per hour and another car moves for 3 hours at the same speed. Find the ratio of distances covered by the two cars. So now, since the speed is constant, we can directly conclude that time is nothing but directly proportional to distance. So can I say that distance of A upon distance of B is nothing but time of A upon time of B? Now, since the time travel for A and B are like 2 and 3 hours respectively, the ratio of distances covered is also going to be what? 2 by 3. And this is the answer. I hope you people understood this, and now I want you to solve the question which is displayed on your screen now. I hope you got the correct answer. So let's move forward. The next topic is direct proportionality between speed and distance. That is when the time is constant. This means that speed is going to be directly proportional to distance. Now here there are 2 points which are very important. Let's understand them. A body travels at s kilometers per hour for the first 2 hours and then at s1 kilometer per hour for the next 2 hours. Here two motions of one body are being described and between these two motions the time is constant. Hence, speed will be proportional to the distance that is travelled. And two cars start simultaneously from A and B respectively towards each other with speeds s1 km per hour and s2 km per hour. They meet at a point C. Here again, the speed is directly proportional to the distance. Since two motions are described where the time of both the motions is the same, that is, it's evident here that the first and the second car travel for the same time. So in such cases, the following ratio that is displayed on your screen will be valid. That is, speed 1 by speed 2 is nothing but distance 1 by distance 2 because what? The time is constant. So speed is going to be directly proportional to your distance. So let's solve a question to understand the concept clearly. Now here, the car travels at 30 kilometers per hour for the first 2 hours of a journey and then travels at 40 kilometers per hour for the next 2 hours of the journey. Find the ratio of the distances that are traveled at the two speeds. So here, can we say that d1 by d2 is equals to s1 by s2? Since the time is constant, between the two motions described, we can use the proportionality between speed and distance, right? And here we can simply write it as 3 by 4. As simple as that, because 30 by 40 is nothing but 3 by 4. Correct. I hope you understood this question. Now I want you to solve the question which is displayed on your screen now. I hope you got the correct answer. So let's move forward. The next concept is based on the inverse proportionalities between speed and time. When distance is constant, that is, speed is inversely related to time. Here we have again 2 points. So let's understand them. A body travels at s1 kilometers per hour for the first half of the journey and s2 kilometers per hour for the second half of the journey. Here two motions of one body are being described and between these two motions, the distance travelled is constant. Hence the speed will be inversely proportional to the time travelled. Two cars start simultaneously from A and B respectively towards each other. They meet at a point C and reach their respective destinations B and A in T1 and T2 hours respectively. Here again, the speed is inversely proportional to the time. Since two motions are described, where the distance of both the motions is same, that is, it's evident here that the first and the second car travel for the distance AB. In this case, the ratio that is displayed on your screen is going to be valid. That is, S1 by S2 is going to be T2 by T1. And if I cross multiply, I'll get this equation. That is, S1 times T1 equals to S2 times T2. Also, if there is a third body, I can also say that S3 into T3 is equal to the S1 into T1 and S2 into T2. And all of this is constant, so I can also say that it is equal to what? K. You can take any constant, P, Q, M, N, O, P, A, B, C, anything. So let's solve a question to understand this. The question says, a train meets with an accident and moves at 3/4 its original speed. Due to this, it's 20 minutes late. Find the original time for the journey beyond the point of accident. So the speed is 3/4. Time becomes 4/3. Now 4/3 of the original time, but the time that is given is 20. That is 20 into 3y, because if 4/3 is the time that is given, then the time which is left is 1/3. So 1/3 is the time left, and 1/3 is of the original time, which is nothing but 1/3 of original time is going to be 20. So 20 times 3 is going to give me original time, that is x, and x is going to be nothing but 60 minutes. It was easy. So I want you to solve the question that is displayed on your screen now. I hope you got the correct answer. So with this, we come to an end of our lecture. Let's recap what all we studied. We started with what is time, speed and distance. We read about the introduction and we understood basically how this chapter is important in CAT and how it can assist other chapters which are in the examination. Next, we studied about the concept of motion and mathematical representation of motion. Further, we studied about the proportionalities implicit in the equation, that is speed into time is nothing but distance. And lastly, we solved some questions. I hope you found this lecture interesting and I hope you understood the chapter. Now you can go to EduRev site and give the respective test to cross-check your understanding. Have a good day.